Hello. Now we are going to look at construction 7. And construction 7 is where we want to divide a line segment into any number of equal line segments without measurement. So let's look at the language involved in that. We have a line segment. The sec or seg part of that means that it's a cutout. So we're cutting up a piece of a line. So we are going to take the cutout of an infinite line from A to F. So there's an infinite line going all the way through A and F, and we're taking a little cutout of that line, so we say it's a line segment. We have cut out a piece of the infinite line AF, and what that would look like here is our line just stops at A and stops at F, and the way we indicate that using geometry language is we have a square bracket past the letter. So we have a square bracket at the A end and a square bracket at the F end, and those are effectively end caps to our line. We're not going to go past those points, and we have our capital letters for our points. So that's what our line segment looks like, and this line segment has been broken up into 5 equal pieces. So we can be asked to do any number of equal pieces of a line segment, and in this case I'm going to do 5. There's no significance to that. You can be asked to do lots of different numbers of line segments, and that just determines the number of arcs that we will draw in, but we'll see that in a minute. So here in my diagram, I have the line segment A to F, and I've broken it up into 5 equal pieces: A to B, B to C, C to D, D to E, and E to F. And all of the lengths between those points, all of the distances between those points are equal. They're equal pieces of the line from A to F, equal line segments in their own right. So the distance from A to B, our vertical lines on either side of the letters mean the distance from. Our square brackets mean line segment, and then our vertical lines means the distance between the points. So the distance between A and B is the same as the distance between B and C, and so on. They're all equal length line segments between A and F, and they're all breaking up that distance equally. So in total, if we add up the lengths from A to B, B to C, and so on, we would end up getting the distance between A and F, or the length of the line segment A to F. So now we're going to look at how we can construct this, and the construction is logically identical to the construction we use for construction 6. So construction 6 and 7 are logically exactly the same. Construction 7 just means that we can be asked to do any number of line segments we break this line segment up into. So I'm going to take my straight edge, and we need to be careful that when we're drawing this, assuming that our line segment that we're breaking up is horizontal, we want to make sure that we have a fairly narrow angle here, a fairly acute angle here, and we are going to want to go a little bit past F when we are drawing this line in to make it easy to do the rest of the construction. So we are going to draw that line in and go a little bit past F if AF is a horizontal line segment. And then we're going to take our straight edge out of the way for a minute, and we're going to take our compass and we're going to open it up, sit it at the point A where we just drew our construction line from, our acute angled line away from AF. Now we need to do a little bit of experimentation here. We want to make sure that when we do 5 of these arcs, so we're going to do a series of arcs down along here, when we do 5 of these arcs all the way down, all equal lengths, they must be equal length arcs as we're drawing them, and make sure the arcs are quite big. We need to make sure that they are clearly visible in our final construction. When we've done 5 of these arcs, we have to get down to around where F is. If it's well away from F, it's going to make the next part of this very awkward to do. So technically it can open up to whatever length we want, but if we aren't careful, if we aren't quite close to the point F, a little bit in or a little bit out from F, assuming this is going straight across, it's going to make the rest of this quite awkward. So be careful. These arcs are all the same length, and we need to do a little bit of a test before we start heavily drawing them that they're going to end up roughly around the point F, so that we're able to do the next part reasonably easily. So now we're going to take a set square, and we're going to line it up so the final arc that we have here has to line up with our point F here. So get that to sit in place and tilt things around until that's going to the point F. So we have our corner of our set square at that final arc, and we have, it doesn't actually have to be the corner, so this line just has to sit against the arc and go through the point F. It's important that they're well aligned. We're now going to do a straight line through those, and then we're going to create a bunch of parallel lines going through where we cross our arc, just like we do for construction 6. So I'm going to change the color of my pen just to keep track of what it is I'm doing. So draw a straight line down through there, and now we need to keep this set square moving in exactly the same direction. We need a bunch of parallel lines, and what we're going to do is use our ruler as a railway to slide along so that we are able to keep going in the same direction. So our ruler is going to be held to the page, and we're going to slide our set square along the ruler so that it stays going in the same direction. So now we're going to slide the set square along until we get to our next arc, as we have here, and we take out our pen and we're going to draw in our line through. Those two blue lines are parallel to each other. They are both going in the same direction. Now we're going to keep sliding along. The real difference and the main difference here is just between construction 6 and construction 7. It's just how many of these we have to do. Try and keep everything as neat as you can. This is easier to do by hand. So keep drawing them along, sliding our set square along. Be careful that that ruler stays in place. It can be worth skipping back and just double checking that everything has stayed in line as we're going. It's very easy for the hand to slide slightly as we're doing our work, particularly as we have more arcs to do. This gets more and more finicky to keep everything straight as we are going over a greater number of crossings. And we want to start thinking about why it is that this is working. So what lengths are going to be the same? What sides are going to be parallel? What shapes can we see? So now we have our construction done. So this is the finalized construction. There isn't anything more to the construction. But why is this working? What we're claiming now is that, change my color one more time. My claim is that this length is the same as this length, 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 all going along. So a single dash means the same length. Going back to my original diagram here, that would be the point B, that would be the point C, that would be the point D, and that would be the point E. Again, this is not construction. We're now talking about where this is coming from, why this is working. What else do I know? Well, I know those arcs were all the same length, so I know that distance is the same as that distance, is the same as that distance, and so on. What else do I know? Well, I deliberately constructed my blue lines to be parallel, so I know that they're all going in the same direction, and I can indicate that with the same number of arrows on my line. So if I draw in all of those things that I know, what shapes can I see that allow me to link to what I know about in geometry to double check that what I am claiming makes sense? What do I know about, what shapes can I see here that would allow me to argue that these line segments all have to be the same length, that they break up A to F equally? Now, just to double check what we were doing, we can take our ruler and just see how accurate were we in our construction. And we can see that this line segment was 15 centimeters long. This was just to make it easy to see that this worked for when we came to this point. So I've gone 3 centimeters, 6, 9, 12, 15. So I have broken these up. A to B is 3 centimeters, B to C is 3 centimeters. They're all broken up into equal line segments, equal lengths that break up our line segment A to F. So that is what we need for now.